Hey gang, welcome to week 3 of Code Club. This week we're going to talk about how to add custom blocks to your Scratch project, how to draw with the pen, and sensing blocks that let you control how your sprites interact. Open up another browser window and log into Scratch so that you can follow along. Have fun and let's start coding. So the first thing I want to talk about today is the More Blocks feature in Scratch. And what More Blocks lets you do is create a new block that's just like, say, the wait 1 second block or the move 10 steps block. It lets you define a bunch of code that's all grouped together. It shows up here in More Blocks, and you can drag it onto your screen into your code as many times as you want. So the first thing you need to do is define a custom block. And the way you do that is this Make a Block button. And it's going to pop up a box here, and the first thing it asks you is for a name, and then there's this little drop down for options. And this has what are called inputs on it. And inputs are basically like variables you pass into your custom block. So I'm going to set up a real simple example. We're going to do say, and then a string input, which is text, so it's going to be called string1. And then I'll add a label, which is just helps to define what your custom block does. It's not a variable. It's just some text in there to help understand what's going on. And then I'll add a Boolean input. And what a Boolean input does is it requires an operator to be passed in so that it can be evaluated as true or false, and it will change the outcome of the custom block based on that. There's also a number input you could use, and then there's also this button for run without screen refresh. And we'll talk about that when we talk about how to do stuff with the pen a little bit later. So here's a real simple definition. Say string1 when Boolean. And you can see it here. And what I'm going to do is add the code to this custom block now. So I want a if then else. And then here's the cool part. These variables, Boolean 1 and string, can be dragged into your code within your custom block definition. So if Boolean 1, then, and here's what I'm going to do. I'm going to have it say string1. And then what I'm going to do is else say Boolean 1 was not true. That way you'll be able to see the difference very easily when you're looking at the program. So now what we need to do is add a when clicked. We do our more. And what do I want it to say? I'll have it just say hello world. And then we need to add an operator so that this Boolean can be evaluated as true or false. And I'll just put an equal sign and do my little 3 equals 3 type of test here. So 3 equals 3. So we know from our previous one on if testing that 3 equals 3 is true. When I run this, it's going to run this custom block, which says if Boolean 1 then. So it's if 3 equals 3, say string1. And that's what it's going to do. It says hello world. Now if I do 3 equals 4, which is false, it's going to drop down into the else instead and say Boolean 1 was not true. So here's a little more complicated example of where you'd want to use a custom block. So what I'm going to have it do here, you can see here I have a length, a width, and an area of a rectangle. And if you remember from math class, length times width equals the area, right? So what I'm going to do is set the size of my rectangle to be 100%, and then I have a custom block here that says get length and width, x position, y position. So for the block with x position, for the sprite with x position and y position of these two variables, and if you see here, it's got current x, current y, it's going to calculate the length and the width of that sprite. So if there's a little thing here that does it, it sets the length, it sets the width, and then it goes back to xy basically. Then I have another custom block that actually calculates the area for the given length and width. So you pass in the length and width variables. If you see here, it says calculate area, length, width. And it says set area to length times width. So if I run this real quick, it makes the block kind of big. It calculates 200 times 100 is 20,000. Resizes it to 99 by 49 and it gets the area for that. And then it resizes it again and get the area for that. So you can see you can use the same groups of code. So I have, the get length and width code in one group and I have the area code in another group, it does those calculations as many times as I want with different variables being passed in. They don't have to be in a loop or anything. That's the beauty of using custom blocks for that. The next thing I want to talk about is the pen system in Scratch, and that lets you draw on the screen using a pen. But before I do that, I wanted to remind you of the XY coordinate system, because the pen relies on things in the motion blocks, which do things a lot like, go to X -90 and Y -100, and glide to X -90, Y -100, or change X by 10, or change Y by 10. And in order to use those, you have to remember what X and Y mean. Right in the middle of the screen, X is 0, Y is 0. As you move right, X goes up. So X goes all the way up to 240, all the way at the right side of the screen. As you move down, X goes down, and it goes all the way down to -240. Then as you move up the screen, Y keeps moving up, and it goes all the way up to Y of 180 at the top of the screen, and it goes down as you go down to Y is -180. You can always see when you're moving your mouse around, right down here in the corner, it shows you what your current X and Y are. And as you move a sprite around, if you look at the info button for a sprite, it'll show you what the X and Y coordinate of that sprite are down here as well. If you ever forget what the coordinate system is, if you go into the backdrop library and go to other backdrops, you can see there's an XY grid here that shows you the XY coordinates on it. So if you're doing something that's very, XY coordinate heavy, you might load that as your backdrop for a while you're planning things out, and then you can just delete it later. The pen blocks let you make some pretty intricate, graphics and drawing and video type stuff by drawing lines on the screen from a sprite. And so, I have this sprite of a tennis ball on here just to have a sprite on the screen. You can do a blank sprite so that you don't see it. You can have some sort of weird graphic like the tennis ball. It doesn't matter, but you need a sprite in order to use the pen stuff. And the basic things you can do are clear the screen of any pen drawings, and then pen down and pen up work just like if you were drawing on a piece of paper with a real pen. The pen down puts the pen down onto the piece of paper. Pen up takes it up off the piece of paper. So just a real quick script here. The pen works in conjunction with the motion scripts to move around on the screen and do the drawing. So we put the pen down. I'm going to have it move 20 steps. And then pull the pen up. Move 20 more steps. And then put the pen down. Move 20 more steps. And then turn 15 degrees. And move 20 more steps. So what this should do is it should draw on the screen for 20 steps. And then pull the pen up. Move 20 more steps without drawing. Then put the pen back down. Draw 20 more steps, turn 15 degrees, draw 20 more steps. So it should draw kind of like a dotted line with a little bit of a curve in it when I run it. You can't really see that curve. It's there just a little bit, but it's there. So that was that drawing. It's real simple, but just shows you the pen up, pen down, and how it interacts with the motion a little bit. The other thing you can do with the pen is do things where you change the color and the shade and the pen size. There's a bunch of blocks to do things like that. So this one, set pen color to, and it's got a little block with a color in it. This one works by you click on that little block and then you move around on the screen and you can see it's changing color as I move to whatever's in the background. So you can change it kind of dynamically based on what's on the screen already. So, if I want it to be this orangey color, I click there, and now that's going to be the pen color that it gets set to. Then let me just clear the screen, and I'll do move. Move 50 steps, and you can kind of see it draws with that orangey pen color. I can also do where I change the pen size. So let's say set pen size to 8. And then motion, and I'll say move 50 more steps. So now what this should do is draw with that orangey color. It should move 50 steps, make the pen size bigger, and then move 50 more steps. So you can kind of see there's two different pen sizes there. The other one is the shade, and so that it doesn't change the color, it changes the shade of the color. So set pen shade to, let's say, 10. And then we'll move 50 more steps. So it'll draw in the old shade of orange. It'll set the pen color to that orange, move 50 steps, change it to size 8, move 50 more steps, and then change the shade to 10 and move 50 more steps, so the last line will look a little bit different because of that shade difference. And you can't see it because it went off the screen, but there's a little tiny bit of it here. It looks like pen shade 10 on that orange color changes it to almost black. So when I was talking about defining custom blocks earlier, I said that we'd talk about this run without screen refresh option later. And now it's later. So what happens when you run a script in Scratch is that between each block of code in your script, there's a little tiny pause. And the run without screen refresh removes that little tiny pause. Most of the time, that pause is not going to cause you problems. But when you're doing some kind of advanced calculations or advanced pen drawing stuff where it needs to draw really fast, you're going to notice the difference. So I'm going to run this script where I hit it actually makes a difference to have this run without screen refresh checked. I'm going to run it 2 times, once with it checked and once without, just so you can see what's going on. So if I run my script, I hit space to run the render function, and you can see it's loading pretty fast. You know, it pauses a couple times in there, but mostly it's pretty fast, and it draws this thing. This is all done with pen drawing. Now if I edit it and uncheck the run without screen refresh option and clear the screen, hit space again. Now if you can see up in the corner here, it's drawing really, really slowly. I'm just going to let it run for a couple seconds here. So as you can see, it's been running for, close to a minute here, and it's barely drawn any of it. So that's the difference, is it keeps going through these, but because it's got that little tiny pause in there, every time it goes through, it takes forever to draw this. Now I'll go back and just change that one little option, that run without screen refresh. Run it again, hit space. And look at that, it's super fast again. So if you're having problems with your code where it seems to be running much slower than you think it should, take a look at that option. Maybe you need to move your pen drawing or whatever calculation you're doing into a custom block so that you can turn that option on or off. Because pen drawing is attached to a sprite, one of the cool things you can do is called stamping. And basically what that does is, as your sprite is moving around on the screen to do your pen drawing, it can stamp the current version of the sprite onto the screen. So I'll just show you what it does. It's probably easier to do it that way. So if you see, it moved 10 steps, stamped. So there's a bunch of extra scratch cats that were stamped onto the screen by the pen drawing stamp tool. Another thing I want to talk about really quick, because you use it a lot when you're doing pen drawing, is this if on edge bounce block. And basically what it does is exactly what it sounds like. If your sprite hits the edge of the screen while it's moving around, it will bounce the sprite. So I have a little simple script set up here that's going to basically point the sprite in a random direction and start it moving. It's going to move 10 steps at a time forever. And if it hits an edge, it's going to bounce. And this is what it looks like. So it just does that forever. There's some weird calculation for how the bounce should work, but as you can tell, it's kind of, you can do like cool symmetrical drawings and stuff if you use this in addition to your pen drawing stuff. The last thing I want to talk about today are some of the other options available in the sensing category of blocks. So we've already used the ask what's your name type of thing and wait and then the answer a lot. So I want to talk about some of the other ones. So there's things to detect whether you're touching something else. So here it's touching the mouse pointer or touching the edge of the screen. There's also, if you have multiple sprites on the screen, you can have a detection for whether it's touching another sprite. There's things for whether you're touching a color. There's things for whether a certain color is touching another color, how far away you are from the mouse pointer or another sprite, whether a certain key has been pressed, whether the mouse button is down, what the mouse's X and Y positions are in that coordinate system, how loud the sound is on the microphone is on the computer, and then some stuff with video that I'll talk about a little bit later. And then there's also a bunch of other, advanced things for, what is the X and Y position of a different sprite, or what's the direction of a different sprite, or the costume name or number, or the size of a different sprite. And then there's also things where you can get, the current year, month, day, that kind of stuff. You can get the username of the person who's using your script. So I'll show you an example of some of these, not all of them. So this is a simple example of the touching color sense. And so if you see here, I have if touching color red, and I have a couple of just random red blocks scattered around the screen. And basically what happens when I hit play, the scratch cat is going to follow my mouse around the screen, and when it hits a red block, it's going to explode. So now scratch cat's following my mouse around the screen. I run into a red block. It detected that because it was touching the color red, and it did the explosion and the scream female and then stopped the script. This example uses the if touching edge or touching another sprite blocks to do some, basically makes it look like this basketball and this baseball are bouncing around on the screen, and if they hit into each other, they bounce away. And if they hit the edges, they bounce away. So I have on the basketball sprite, I have if touching edge or touching baseball, it moves -10 steps and points in a different direction. And then inside there, if it's touching the baseball, it also plays the water drop sound. And then the baseball has almost the exact same script, except it says if touching basketball instead of if touching baseball. So I'll just run it real quick just so you can see what's happening. So they bounce around a little bit, they touch, play the water sprite when they touch each other. They bounce off the edges. So this is just a real quick example to show you some of the different things available in this block right here that right now it says X position of Abby. But if you drop it down, you have lots of different choices. X position, Y position, direction, costume. And you can also actually change it to different sprites and to the stage to get some information about the stage as well. So this, it shows you the X position of Abby, the Y position of sprite 1, and the backdrop name that's currently on the stage, just to give you an example of some of the things that are in there. So Abby is in the 86 X position, Cat is in the 0, and the backdrop is backdrop 1. So just some simple example of how to use some of the different information in there. So this is going to show you how to use the distance to block. And if you look, it's got two different options here. One is for mouse pointer, which is the distance to the mouse pointer on the stage. And then the other is the distance to a different sprite. And so if you see, I have another sprite on here called Origin, which is actually empty. There's nothing actually in the sprite, but it's positioned at X0, Y0, which is right in the middle of the screen there. And so the first one I'm going to show you is this sets the pen color to the distance to origin. And so it centers it right in the middle. Hit space, it's going to draw. It centers it right in the middle. And depending on how far away it is from the origin, that's how it sets the pen color. If I change it to be distance to mouse pointer, let me restart here. So right now the mouse pointer's here. That's where it's going to center the drawing. If I change it to over here and hit space again, that's where it's going to center the drawing. So it kind of, it uses the current X and Y position of the mouse pointer, calculates the distance to that, and that's how it draws the screen. When Scratch starts up initially, it starts a timer in your program. You can see it counting up right here. It's already at 18 seconds from when my screen loaded up. And there's a variable you can use to look at what is in that timer. And you can also reset the timer. So you can do something in your program like, you have somebody do a task in your program and you want them to do it in less than 5 seconds. You can use this timer variable to see if they're at less than 5 seconds or not. So like I said, it counts up every second. You can watch it happening. When you click the green button on your program, it will reset it back to 0. So if you look at my program I have here, I just have it saying the timer every 2 seconds. So it's going to say here pretty much 0 and then 2, 4, 6, and then it's going to reset the timer and go 2, 4, 6, 8. So you can just kind of see that happening here. So it's 0.15, then it'll be 2.17. So it counts up a little bit every time, resets it to 0, and then it does 2, 4. And then if you look up in the thing here, even after my program has stopped, the timer in this corner is still running. The last example I wanted to show you is the video operators. And what those do, if you have a camera attached to your computer, it can detect the motion happening in the video and do things based on it. And the two big things are the motion and the direction. And so the motion is how much motion, if you're moving a lot or just a little bit, and then the direction is what general direction that Scratch thinks the motion is happening in. And the way I'm going to show you how this works is I have this little program set up here where if you have a camera hooked up, when you're moving around, it looks like you can push ScratchCAD around on the screen. He kind of turns in the direction that you're pushing and then moves in that direction as well. So I'm going to start the program here, and it'll start my camera. You can see me moving here in the background. ScratchCAD's already moving around a little bit. But if I start moving my hand in, you can see he's moving away from my hand. Do the other direction, push him up. So there you can kind of do some, if you have like a Wii or a Kinect where it's got motion sensing on your game console, it kind of does that sort of interaction, but it's a lot more simplified because it's just detecting the video and the motion of the video in the background. The basic blocks that you use to do this are the turn video on and turn video off, which I'm going to do right now. And then you can set how transparent it is. So for example, if I set my transparency to 100 and then I run this, it's not going to show you me in the background anymore because it's not transparent, but I'm still moving my hands around. You can't see me. I'm still moving my hands around, and that's still moving ScratchCAD around. And then the other thing is, I'm detecting motion, and I kind of had to play around. I have the number 13 in here. That might be specific to my video camera, actually. But this is how much motion it detects. And then the direction is, if you watched, let me set this back to 50 like I had it before so you can see me in the background. It's kind of moving in the same direction that I'm moving my hand, and that's what makes ScratchCAD move around. So it does some detection in the video to see that's the direction this guy's hand is moving. So you can also do a similar thing with just the loudness of the microphone on your computer. So you can see I have the script here where it checks the loudness in a loop, and if it's getting louder and louder, then it will move ScratchCAD across the screen. So you can see here, as I'm talking and getting louder and louder, ScratchCAD is moving across the screen. But it gets to a point where it's too loud and it'll stop moving. But that's just a real simple example of how the loudness can interact with a sprite as well. Okay, that's it for week 3. I hope you enjoyed it. Now go do some coding on your own. Have fun, be creative, and we'll see you next week.